All right, moving into our final group, Group 3. And when I read the first presenter, I thought we had a celebrity in the mix. But no, this is not Tyler Perry of Medea fame. This is graduate student Tyler Perry, and his pitch presentation is Crossed and Uncrossed Visual Motor Reaction Timing Training. Take it away.
This year, I'm very lucky to be able to travel to the Olympic Training Center and work with our U.S. Olympiads. They have very extreme reaction times, but also a high incidence of mild traumatic brain injuries, commonly known as concussions. Concussions can cause damage in the brain in various structures, but specifically I want to look at the corpus callosum. The corpus callosum is located between our hemispheres and is very key in integrating and processing information between the hemispheres. Incidentally, it is also very important in visual input and motor intention, which I will be looking at in this study. So, visual input, simply put, is left visual field and right visual field. Our left visual field is actually controlled by our right hemisphere. Our right visual field is actually controlled by our left hemisphere. So the corpus callosum is necessary to integrate this information and give us a full picture. To be able to simulate that, we're going to be doing visual reaction time training with an LED touchscreen called the Reflection Edge, which we will be doing cross and uncrossed trials with. A cross trial will be right hand to left visual field. Uncrossed trial will be right hand to right visual field. We also have the difference between those two variables, which is a good signifier of motor intent, which is my other variable. Motor intent is the process of taking the sensory information and putting it into motor and muscle movement. We will then be doing an 8-week full body reaction time training session with the TRASER system, which is a computer simulated program where you'll be responding to stimuli on the screen in full body movements. We will then come back and test their peripheral visual reaction time test, or reaction times. We'll be wanting to see if there's a correlation or difference between the first and the last visual reaction time testing, which could signify that these processes share the same pathways, motor intent and visual input, and can be damaged by concussions. We want to see long-term if this is an objectifiable, cost-effective, and easily accessible way to identify concussions, identify the integrity of structures in the brain that are affected by concussions, and therefore either train to prevent or rehabilitate neurocognitive deficits that occur within these concussions. Thank you guys for your time.